Good morning, dear students. Today I will discuss about Venn diagram and operation on sets. Let us start with Venn diagram. Representation of sets by using diagram is called Venn diagram. Venn diagrams are named after English logician John Venn. So John Venn invented Venn diagram, and let us explain this with an example. Suppose U equal to the universal set U equal to 1, 2, 3, 4, 5, and let A equal to 1, 2, 3. 1, 2, 3, 4, 5 and 1, 2, 3. First, we mark the universal set U by a rectangle, and inside this I have drawn a circle to represent the set A. 1, 2, 3 are elements of A, so I have written 1, 2, 3 inside A. 4, 5 are not elements of A, they are elements of U. So I have written 4, 5 outside the set A. So the universal set U contains the elements 1, 2, 3, 4, 5, and A is a subset of U. This is representation of A by using A and U by using Venn diagram. Later we will explain union intersection of sets by using Venn diagram. So this is just beginning of Venn diagram. Venn diagram means representation of a set by using diagrams. Next, operation on sets. Let us start with union of sets. Let A and B be any two sets. The union of A and B is the set which consists of all the elements of A and all the elements of B. All the elements of A and all the elements of B. The common element being taken only once. The symbol U is used to denote the union. The symbol U is used to denote the union. Symbolically, we write A union B to represent union of the sets A and B. A union B. Let us take one example. Suppose set A equal to 1, 2, 3, 4. Set B equal to 2, 4, 6, 8. A union B equal to A union B means all the elements of A. I have written 1, 2, 3, 4. Then all the elements of B, 2, 4, 6, 8. The common elements, the elements which are common to both A and B, we have to write once. So 1, 2, 3, 4, first we have to write. Then the elements which are in B, we have to write 2, but I have already written. So next 4 is also written here, 1, 2, 3, 4. The remaining two elements are 6 and 8. So 1, 2, 3, 4, 6, 8. All the elements of A and all the elements of B. The common elements we write once. This is the Venn diagram representing A union B. Suppose this is the set A, this is the set B. A union B means all the elements of A and the elements of B. All the elements of A. Mathematically, we have to remember A union B means all such elements X which are in A or in B. All such element X where X is either an element of A or an element of B, or in both. Maybe X belongs to in both the elements, but an element of A union B means it is either in A or in B, either in A or in B, or maybe in both. But A union B, by A union B, we mean the set of elements which are either in A or in B. So next, properties of union of sets. Properties of union of sets. Number one property, A union B is equal to B union A. A union B is equal to B union A, which is commutative property. A union B union C, A union, then within bracket B union C is equal to A union B union C, which is called associative property. In class 8, if you can remember, in class 8 we got A plus B plus C is equal to A plus B plus C. This is called associative property of natural numbers or real numbers with respect to addition. A plus B plus C is equal to A plus B plus C. This is associative property with respect to addition. Similarly, this is associative property with respect to for union of sets. Associative property for union. A union B union C is equal to A union B union C. Number 3 property. A union phi is equal to A. As phi contains no elements, A union phi means all the elements of A plus all the elements of phi, but phi does not contain any element, so A union phi is equal to A. This is called law of identity elements. Next, A union A is equal to A. A union A is equal to A. This is called idempotent law. Universal set U union A, because universal set, all, if we take any set, that will be subset of the universal set. It's the bigger set, the smaller set. Universal set union A is equal to always U. This is called law of U. Next, let us move to intersection of sets. The intersection of sets A and B is the set of all elements which are common to both A and B. Which are common to both A and B. The symbol intersection is used to denote the intersection. This is a symbol for intersection of sets. And symbolically, we write A intersection B. A intersection B. A intersection B means the elements which are common to both A and B. I have drawn Venn diagram here. This is the set A, this is the set B. This is the common part. A, the elements which are common to both A and B. This is called intersection of sets. Let us take one example. Suppose A equal to 1, 2, 3, 4 and B equal to 2, 4, 6, 8. A intersection B is equal to, we have to collect the common elements, 2, 4, 2, 4, so 2, 4. A intersection B means 2, 4, the elements which are common to both A and B. Next, we have to remember, like union, A intersection B means all such elements X which are in A and in B. X belongs to A and X belongs to B. A intersection B means all such elements X which belongs to A and which belongs to B. X belongs to A and X belongs to B. X must be common to both A and B. X must belong to both A and B. And you can see the union A union B equal to all such element X, where X is either in A or in B. X may be in A or in B. If X belongs to A, then X will be an element of A union B. If X is an element of B, then also it will be an element of B. The X may not be common to A and B, but X will be element of A union B. So A union B means all such element X which are either in A or in B. And A intersection B means all such elements X which are common to both A and B. X belongs to A and X belongs to B. For union, it will be OR. For intersection, it will be AND. You have to remember. Next, properties of intersection of sets. Properties of intersection of sets. Number 1, A intersection B is equal to B intersection A. This is called commutative law. A intersection B is equal to B intersection A. Next, A intersection B intersection C is equal to A intersection B intersection C. A intersection B within bracket intersection C is equal to A intersection B intersection C. This is called associative property. Number 3, phi intersection A. The elements which are common to phi and A. Phi, there is no element in the set phi, so their intersection will be phi, because phi has no element, and therefore nothing will be common to phi and A. So phi. U intersection A is the bigger set, this is the smaller set. So U intersection A will be equal to A. This is called law of phi, this is law of U. And A intersection A is equal to A. This is called idempotent law. Idempotent law. So these are properties of intersection of sets. Next, distributive property. Distributive property. Now, how to remember distributive property? In class 8, we got distributive property of multiplication over addition, A cross B plus C. A cross B plus C is equal to A cross B plus A cross C. This is distributive property of multiplication over addition. Exactly in the same way, you can see this is distributive property of union over intersection. A union B intersection C. Like this. A cross B plus C. First A cross B plus A cross C. You can see A union B intersection C. A union B. First I have written here. Then intersection A union C. This is distributive property of union over intersection. And similarly, A intersection B union C equal to A intersection B. A intersection B union A intersection C. A intersection B union A intersection C. This is distributive property of union over intersection, distributive property of intersection over union. Very important properties, useful properties. Next, I have taken two examples from NCERT book. Find the union, intersection of each of the following pairs of sets. Number 1, x equal to 1, 3, 5 and y equal to 1, 2, 3. 1, 3, 5, 1, 2, 3. Union. Union means first we put all the elements of x, 1, 3, 5, and then the rest of the elements of y, which are not common to x. You can see 1, 3, 5, 1, 3 are already there in x. The remaining element is 2. So 1, 2, 3, 5, x union y. Elements of x plus elements of y. Common element we have to write once. Next, x intersection y. X intersection y is the common element, so I have written 3. Next, example number 2. X is a natural number and multiple of 3. X is a natural number and multiple of 3. And b equal to, set b equal to x is a natural number less than 6. Okay. A equal to x is a natural number and multiple of 3. So x is set A equal to set of all natural numbers multiple of 3. So A will be 3, 6, 9, 12, 15. These are all multiple of 3 and these are natural numbers. B equal to x is a natural number less than 6. So B equal to 1, 2, 3, 4, 5. Their union will be all the elements of A plus all the elements of B. The common element we have to write once. So first I have written elements of B, 1, 2, 3, 4, 5. Then 3 I have already written. Then 6, 9, 12, 15, etc. Now here in question, A and B are given in set builder form. So we will try to write the answer. Always if question is given in set builder form, generally we will write the answer in set builder form. If it is given in tabular form, we write the answer in tabular form generally. So as it is given in the set builder form, we will write the answer in set builder form. So how I have written x, in both the cases x is a natural number, so x belongs to n, x is a natural number. As it is union, I have connected in this way. I have write first the properties of the elements of x. X is a natural number. I have written x is a natural number and multiple of 3. I have written x a natural number, x is a multiple of 3. Union means OR. X is a natural number less than 6. So I have written the common property of the elements of A connected by OR, then the common property of B. X is a natural number and multiple of 3. X is a natural number and multiple of 3. OR, union means OR. X is less than 6. Multiple of 3 or less than 6. Whenever we write for union, we combine union by using the letter OR. Intersection, A intersection B. The common element is 3 only, so I have written 3. And how I have connected, you can see x is a natural number, x is a multiple of 3, and less than 6. For union, I have written OR. For intersection, I have written AND. Okay, you have to remember in this way. Union means OR, intersection means AND. The elements which are in A and in B, intersection, which are elements which are either in A or in B, or maybe in both, but we write either in A or in B, union. Next, I have taken another example. Set A equal to 1, 2, 3, set B equal to 5. There is no element in this set, 5 means empty set. So A union B will be first elements of A 1, 2, 3, and there is no element in the set B, so it answer will be 1, 2, 3. Okay. A intersection B, A intersection B. B contains no element, so there is nothing common in A and B, so answer is 5. Similarly, try to solve the homework, which will be question number 1 and 4. Question number 1 and 4 of NCERT book. So try to solve this problem. First go through the definition and then try to solve the problems. This much for today. Thank you.